What is generative AI and how does it work? Generative AI is a subset of artificial intelligence that creates new content, data, or solutions by learning from existing information. Unlike traditional AI, which relies on pre-programmed instructions to make decisions or predict outcomes, generative AI produces original outputs, such as text, images, audio, and even code, based on the data it has been trained on. These systems are capable of creating diverse content, making generative AI essential in fields ranging from creative industries to data synthesis and scientific research. Understanding generative AI. Generative AI systems are designed to mimic human creativity and learning processes. Rather than simply identifying patterns or classifying data, generative AI takes things a step further by constructing new, coherent, and realistic outputs. It can produce text, writing coherent and contextually relevant passages like articles, stories, or even code. Images, generating realistic images, art, or illustrations based on descriptions. Audio, creating music, sound effects, or voices. Video, synthesizing video content or animation sequences. This process relies on machine learning, ML, and deep learning models, which learn from large datasets to improve their understanding of structure, context, and style in different media. How does generative AI work? The magic of generative AI lies in its use of complex models, most notably neural networks and advanced algorithms. Here's a breakdown of the key components and how they function. 1. Neural networks. Neural networks, inspired by the human brain, are at the heart of generative AI. A neural network consists of layers of interconnected nodes, neurons, that process input data and pass it through multiple layers, refining its understanding at each stage. Two popular types of neural networks in generative AI include convolutional neural networks, CNNs. Often used in image generation, CNNs excel in processing spatial information, making them suitable for image and video synthesis. Recurrent neural networks, RNNs. Used for sequential data like text and speech, RNNs retain information from previous inputs, making them effective for natural language processing tasks. 2. Generative adversarial networks. GANs are one of the most influential developments in generative AI. Created by Ian Goodfellow in 2014, GANs consist of two neural networks, a generator and a discriminator, that work in tandem. Generator creates new data by learning patterns in the training data. Discriminator evaluates the generator's output against real data, determining if it's realistic or not. This process of feedback and refinement allows GANs to generate highly realistic outputs, from lifelike images to synthetic voice recordings. Number 3. Transformers. Transformers are another type of architecture that has revolutionized text-based generative AI. Introduced in 2017, transformers, like the popular GPT, Generative Pre-trained Transformer model, are designed to handle long-range dependencies in data, making them particularly effective for language tasks. They use mechanisms like self-attention to focus on specific parts of the input data, which allows them to generate coherent and context-aware text. Transformers are the backbone of language models like ChatGPT and BERT, powering everything from text generation to question answering. 4. Diffusion models. Diffusion models have recently become important in generating images, particularly in models like DALL-E and Stable Diffusion. These models work by gradually transforming a random noise image into a coherent picture. Through multiple iterative steps, they add and remove noise to produce a clear, high-quality image that matches the prompt or description provided. Applications of generative AI. Generative AI's capabilities are transforming numerous industries by creating value in unique and innovative ways. Here are some of the primary applications. Content creation. Generative AI powers tools that create written content, such as articles, summaries, and social media posts. These systems help marketers, writers, and businesses generate copy quickly and consistently. Image and video generation. With the help of GANs and diffusion models, generative AI can create realistic images, illustrations, and animations, aiding industries such as design, advertising, and media production. Healthcare and drug discovery. In the pharmaceutical sector, generative models analyze molecular data to design new drugs, simulate protein structures, and accelerate the discovery process. Customer service and virtual assistants. Advanced natural language processing, NLP models create intelligent, conversational AI agents capable of handling customer queries, offering personalized responses and learning from each interaction. Data augmentation and simulation. Generative AI can synthesize data that mimics real-world scenarios, allowing companies to train ML models without privacy concerns and helping industries like robotics and autonomous vehicles simulate complex environments. Gaming and virtual worlds. In gaming, generative AI creates unique characters, dialogues, and world elements, offering players personalized and expansive experiences. Challenges and risks of generative AI. While generative AI offers groundbreaking possibilities, it also presents challenges and ethical considerations. Misinformation and deepfakes. Generative AI can create hyper-realistic media, including deepfake videos, which can be misused for deception or disinformation. Addressing these risks requires careful regulatory frameworks. Bias in data. Generative models learn from the data they're trained on, and if that data contains biases, these biases can be reflected in the AI's output. Ensuring fairness in generative AI remains a critical focus area for developers. Intellectual property concerns. As generative models can replicate styles or elements from training data, issues related to copyright and ownership have arisen, especially in the arts and entertainment sectors. Environmental impact. Training large AI models consumes significant computational resources, leading to high energy consumption. Efforts to make generative AI more energy efficient are ongoing but remain a concern for sustainable AI development. The future of generative AI. The evolution of generative AI is poised to accelerate in the coming years, with expected advancements in multimodal generative models, AI systems that can understand and generate multiple forms of data, such as text, audio, and visuals simultaneously, are becoming a reality. This would enable seamless interaction across media, making AI even more versatile. Improved control over AI outputs. Developing models with greater control over the style, tone, and specificity of generated content is a priority. This will make generative AI more customizable for various professional applications. Ethical AI development. As generative AI becomes more prevalent, ethical considerations will drive research and regulation, aiming to protect users and ensure AI is used responsibly. Generative AI is transforming the landscape of creativity, productivity, and problem-solving. By creating realistic and innovative content autonomously, it not only expands what AI can achieve, but also pushes the boundaries of human-computer interaction. With responsible development and regulation, generative AI holds the promise to benefit diverse fields, making it one of the most exciting frontiers in technology today.